All right, here's how you can use DESMOS to find the best line, a fit or function that describes some data. And this example is a quadratic example. First thing, I've typed in all my data, but I don't see any of it on my screen. And that's because the y values are so high. So I'm going to hit this wrench there, and I'm going to change my values. The lowest x I have is 10. I'm going to maybe start that a little bit lower, so 0. And the highest x I have is 64. Maybe I'll go to 70. I'll go to 80. Whoops, 80. And then the y values, the smallest one I have looks to be 115, so I'll maybe start at 100. And the highest one goes 285. I'll maybe go to 300. There. Now you can see my dots. And they do look like they would form some kind of upside down parabola or a quadratic function. So now I can tell DESMOS to give me a path that sort of is an average line that hopefully joins a lot of those dots, or is an average line of the dots. To do that, you type y1, and that comes from the y1 at the top of that table. So y1 and then a tilde instead of an equal sign. And the tilde tells DESMOS, hey, I want you to come up with a line that describes this data. Okay, and I'm going to use the vertex format for this, so I'm going to go A, and then bracket x1 minus h bracket squared plus k. There, so it gives me that green line. Looks pretty good. Yeah, it looks fairly like it's an average line of that. Okay, so now that I have had DESMOS determine some variables or the function that those dots would represent, now I need to put all that data there back into where the A, H, and K are. So this line, that green line, I could write it as y is equal to, the A value is negative, let's go to 2 decimal places, negative 0.17, and then x minus the h value is 41.77 squared plus my k value 281.58. So when they say use DESMOS to model the thing with a quadratic function, this is what I'm looking for. There's your quadratic function. And I guess what I could do, instead of calling it y there, I could call it an f of x. So it's in functional notation. Okay, then the next question says, what is the optimal angle for the longest hit? And then it says, if the angle hit is 80, how far will it travel? Let me go back into DESMOS and show you how that would work. All right, so if you're wanting to find some other information about this quadratic function, now that we have it there, one of the questions is, how long will it be till it gets to the highest height? And what I can do with that is I can just, on my graph here, tap where the vertex is. Now the vertex should be the numbers that we have on the other page there, earlier on the slide. Well, I guess they get them right underneath there, the A, H, and K that are down underneath that Y1 tilde thing that I typed. So there's your vertex there. Another question was asked is, the X values are angles that you hit the ball at, and they asked how far will the thing go if the angle you hit it at is 80. Now I could just plug an 80 in for X, that should work too, but I can also, here in DESMOS, just type out, if they want to know what X is equal to 80, if they want to know what that is, not dot 80, I can do that. Now, I don't see it on my screen there, but if you look to the right there, there's where 80 is, that blue line. And where it crosses my quadratic graph, that's what the height will be. Height? Yeah, the height will be, is it height? I got to go back to my thing to see what each of those things are. But if you hit an angle of 80, I think that's feet. So if you hit the ball initially at an angle of 80, it's going to travel 26.711 feet or meters or whatever it is. Okay, so you can use DESMOS to help you with that. Yeah, so here I'm back and explain everything. So this 80, that's the angle that you hit the ball at, and the distance that the ball would travel would be the 26.711. Okay? All right, hopefully that helps you understand how to use DESMOS to do that quadratic regression.